Hello everyone, so now I'm going to explain about the question for sequential MSI. The question is, develop the sequential circuit irregular counter using TP-floor and other logic gates. Okay, this is the state transition counter. So the first step we have to do is determine this is how many bits of the binary. So the maximum number is 7, so it is 3-bit binary. So we use 3 flip-flop. The next step is we change all the decimal number here to binary. Like 2 is to 0, 1, 0, 1 is 0, 0, 1, 5 is 1, 0, 1, and so on. Okay, after we convert to binary, we can do the table. The table is like this. We have two columns. Which is present state and next state. And then each column has Q2, Q1, and Q0, which is Q0. So we fill out the present state first. 0, 0, 0, 0, 0, 1, 0, 1, 0, and fill out until 1, 1, 1 accordingly. After finish filling out, we can go to the next step. The next step is we can refer to the present state. So how to refer? We can see the first row, 0, 0, 0. Okay, we find at the step transition counter. Where is 0, 0, 0? Okay, 0, 0, 0 is 0. So the next step is 4. 4 is 1, 0, 0. And then we fill out 1, 0, 0. And then 0, 0, 1. The next step is 1, 0, 1. So we fill out until the 1, 1, 1. We fill out the next step. And then the table is finished. So the next step we can do a table also. The table has 3 columns, which is Q, Q plus, and T. Q refers to present state, Q plus is next state. So when Q is equal to 0, Q plus is 0, and then T will be 0. And then Q equal to 0, you change to 1, and then T will be 1. Q equal to 1, and then we decrease into 0, T will be 1. When Q is 1, Q plus is also 1, remain unchanged, it is still 0. So we can now develop the T0 map, T1 map, and T2 map. So the first thing is fill out the column. So how to fill out? So we can refer to the small picture here, which is from the last slide. So the first row is 0, 0, 0 for present state, right? So 0, 0, 0. For this is the T0 map, right? So we can only see the Q0. We can refer to the Q0. So Q0 at the 0, 0, 0 is remain unchanged, which is 0 to 0, still the same. So the T will be 0. So we can fill out the 0, 0, 0 column here as 0. So we can, and for example, another example, 0, 1, 0. 0, 1, 0 is, we refer to the Q0 column, 0 at the present state, and next state is 1. So 0 to 1. So the T will be 1. So we can fill out the 0, 1, 0 column with 1. So we can continue to fill out. Okay, so after this, we can form groups. We choose one, right? So we form 3 groups here. This is like what we do as the K-map. So T0 is, after we choose 3 groups here, we can do the equation. So the T0 equation is Q2 bar Q1 plus Q2 Q1 bar plus Q2 Q0. So Q2 bar Q1 plus Q2 Q1 bar is equal to Q1 plus with a circle Q2 plus Q2 Q0. So this means Q2 plus with a circle Q1 is means exclusive of OR gate. We use exclusive OR gate. And then we can do the T1 map also. The process is the same, but just now we can refer to the Q1. And then we will get the equation like this. T1 equal to Q2 bar Q1 Q0 bar plus Q2 Q1 bar Q0 bar. And then as well as the T2. And then we will get the equation like Q2 bar Q1 plus Q2 Q1 plus Q2 Q0. Okay, so we go to the next slide. Okay, now we can develop a sequential circuit with the equation we get before. For the first slide, right, we say we have 3 flip-flop. So we have 3 T flip-flop like this. The square one. We have 3 square, right, which is referred to flip-flop. One is for T0, one is for T1, and one is for T2. So now refer to T0 equation first. We have a exclusive OR gate and AND gate. And then we plus these 2 gates. We have an OR gate. So for this one, we link the exclusive OR gate to Q1 and Q2. So we can see there Q1 and Q2 we link to the Q1 and Q2. And then we link the AND gate to Q2 and Q0. And after this, we combine the 2 gates with a OR gate like this. So the output come out will equal to T0. So we connect the output to the T0. So for the second equation is same also. We have 2 AND gate and then with a OR gate. So 2 AND gate we draw first, and then we link to Q2 bar, which we can see there is a bubble. So this is referred to bar. So for the first AND gate, we link to Q2 bar, Q1, and Q0 bar. And then the second AND gate we connect to Q2, Q1 bar, and Q0 bar. And then we combine with a OR gate, and then the output will link to the T1. And then for the T2 is 3 AND gate with 1 OR gate. So the first AND gate we connect to Q2 bar and Q1. The second AND gate we connect to Q2, Q1. And then the third AND gate we connect to Q2, Q0. And then we combine 3 this AND gate into a OR gate. So the output come out will become we connect to T2. And then the last step we have to link all the clock T0, T1, T2. We have to connect all the clock here. So the sequential circuit is done. And then that's all from me. Thank you.